Welcome to Chemistry Sea World.
Hi guys, welcome to Chemistry Sea World. Today we are going to be discuss that ionic bond. So before going to the video, please do subscribe my channel and like the videos, share the videos. Thank you. And in the previous video we learned about what is chemical bonding and how it is going to be formed, what is the need of a chemical bond, and which elements are undergoing for chemical bonding, and that all we learned in that, and types of chemical bonding. Also we are going to be classify them into the strong and weak what you can call chemical bonding. In that strong chemical bonding we are going to be learned that first one is ionic bond. Still there are three more, like a covalent bond, dative bond and a metallic bond, and today we are going to be discuss that ionic bond. So what is mean by ionic bond? So in this ionic bond, so there will be involved in the ions, that's why we can call it as ionic bond. It is also known as electrovalent bond. It is also known as electrovalent bond. So why we can call it electrovalent bond, we are going to be see the now. So the first of all we should, if you go for definition this, so ionic bond definition, if you are going to be see that the electrostatic forces attraction between the two ions, the electrostatic force of attraction between the two ions is called as what we can call ionic bond. Otherwise we can say that two oppositely charged ions, when they are going to be combined and we get a ions. For this formation of ionic bond we required one cation and as well as one anion. To formation of cation we required that metal atom. So let me take in that A atom. So A is going to be lost one electron and it is going to be form a cation. So one metal atom should be required and metal ion, and metal atom is going to be formed a cation. So metal atom is going to be form a cation, and when we are going to be taken the non-metal atom, so it is going to be form a what you can call, that is by gaining of an electron it is going to be form a anion. It is going to be form a an ion. So when we are going to be combine these two, cation and anion, are called what we can say that ionic bond, A plus and B minus. So this is what we can call it is ionic bond. So for ionic bond we require that one metal atom and another one is one non-metal atom. If you are going to be observe that, so here the metal atom is going to be transfer the electron to the non-metal atom. So the metal atom is going to be transfer the electron to the non-metal atom. So let me go with an example and we'll understand very clearly this. So let me go with an example, sodium chloride. So how to formation of sodium chloride in between this? So we are going to be have the ionic bond. So in the between sodium and chlorine atom there is ionic bond. How it is going to be formed, we will see that. So there is a sodium atom which are having the electronic configuration 1s2, 2s2 and 2p6, 3s1. It has in outermost shell there is one electron. So to attain the what you can call octet configuration, it's required still more 7 electrons. So it is impossible to get 7 electrons, that's why it is going to be lost one electron and it can form a sodium plus ion. So we will get sodium plus ion by loss of what you can call one electron, and it is going to be attain the stable configuration in their outermost cell. So this is about sodium plus, and we will go for chlorine atom. Chlorine atom have the electronic configuration, that is 1s2, 2s2, 2p6 and 3s2, 3p5. So this is the electronic configuration of chlorine atom. If you observe here, there are 7 valency electrons. It required still more 1 electron to attain the stability, that means octet configuration. So by taking 1 electron it become what happen, Cl minus, it become the Cl minus, and it is going to be fulfill their outermost cell electronic configuration with 8 electrons. So this is what we can call, it is going to be attain the 8 electrons in their outermost shell, and it is become stable. But what will happen, how it is going to be get 1 electron? So when these two combine, so that means when the sodium atom is going to be combined with, so when we are going to be represent with Lewis dot structures, this sodium atom and chlorine atom, sodium atom has that 1 electron and chlorine atom has that 7 valence electrons, with Lewis dot structures. I am going to be representing here. So let me take in this one in the form of like a cross. So when these two atoms are going to be combined, Na cross and Cl 1, 2, 3, 4, 5, 6, 7. So when they are going to be taken like this, so we are going to be here, the metal atom is going to be transfer 1 electron to the non-metal atom, and we are going to be get like this Na plus, and we'll have that Cl minus atom. We are going to be get a bond formation between the sodium and chlorine atom, and finally we are going to be written like this, sodium chloride. So once again I am going to be define here ionic bond. The ionic bond is going to be formed between the metal and non-metal atoms. Here one metal atom is going to be transfer the electrons to the non-metal atoms. Otherwise we can say, we can define like this, the electrostatic forces of attraction between the two atoms is also known as what you can call ionic bond. The two oppositely charged particles, so when they are going to attract each other, this is also called as ionic bond. So if you are going to be observe here, so there are mainly we require that cation and anion. Now we should know with what is the how the cation is going to be formed very easily, how the anion is going to be formed very easily, what are the favorable conditions we are going to be learn, then we can understand very clear the ionic bond. Okay na? So let me go with the favorable conditions. Favorable conditions for cation and anion. If you observe here, the favorable conditions for cation, low ionization energy element will have what you can call faster formation of cation and low charge on ion and large atomic size and cation with inert gas configuration. So let me explain with one by one. Low ionization energy. If you are going to be observe that 1A group elements, there are lithium, sodium, potassium, rubidium, cesium and francium. So if you are going to be observe these elements, so which has low ionization energy, generally the ionization energy from top to bottom in a groups, it is going to be decreases. Why? Because so atomic size is going to be increases, so ionization is going to be decreases. So there is a formation of Cs plus ion is going to be more favorable, and it is going to be form a strong ionic bond and remaining when you are compared to remaining. So here, so cesium plus, rubidium plus, K plus and Na plus and lithium plus, when we are going to be compare this, cesium plus is going to be formed more. For example, let me take in that NaCl, KCl, RbCl and cesium chloride. When we are going to be formed these compounds, this is a most favorable compound, and this is a strong bond formed between these two atoms when compared to this is the one. And low charge on ion. When we compare the ions charges, let me take in the ions like Na plus, Mg2 plus and Al3 plus. When we are going to be taken these three ions, so this is having low charge. So when we are going to be compared to Mg2 plus, it has low charge. When we are going to be compared to aluminum 3 plus, it has low charge. So which is more favorable means we are going to be have that sodium plus ion is going to be more favorable to form a what you can call cation. So it is a low charge ion. Low charge ions have the what you can call form a stronger ionic bond. So next one is large atomic size. We already know that. So in a first year group elements, if you are going to be observe that from top to bottom, the atomic size is going to be increases. So cesium, it is having that large atomic size when compared to remaining elements. So when we discuss here these compounds. So cesium chloride is going to be formed a what you can call strong ionic bond. So cesium has that large atomic size, that's why we are going to be have like this one, okay na, right. And some elements have that inert gas configuration, some are do not have inert gas configuration. So we'll see that what are that. So elements with inert gas configuration, for example sodium plus form with inert gas configuration, that is NS2 2S2 2P6. So this is having that inert gas configuration in their outermost shell. So like this cations are favorable to form a what we can call ionic bonds. When we are going to be observe these anions, we have this, what are the anions favorable conditions. First one is electronegativity, high should be there, or electron affinity also high should be there. What is electronegativity, man? Electronegativity, when we are going to be taking a covalent bond, when we are going to be taking a bond, the paired of electrons pull towards itself. One of the atom is going to be, the pair of electron is going to be pulled electron towards itself, that is called more electronegative atom, we know that. So in a periodic table, the fluorine has more electronegativity value, that is 4.0, and this is a more electronegativity value. And electron affinity, what is mean by electron affinity? The amount of energy is going to be liberated or absorbed when electron is added to their outermost shell in their gaseous state, and this is called as an electron affinity. So generally the electron affinity is going to be increases along the period when we are going to be observed that we require that high electronegativity or high electron affinity. When we are going to be compare this carbon, nitrogen, oxygen and fluorine is going to be formed, fluorine ion is going to be formed, negative ion is going to be formed more easily when compared to these things. So like that. Next one is low charge on ions. When we are going to be taken F minus, O2 minus or N3 minus, so it is going to be have the low charge, which has low charge ion, that anion is going to be more favorable for ionic compounds. And also small atomic size. So when we are going to be observe that 7th group elements, that is 17th group elements, fluorine, chlorine, bromine, iodine. So from top to bottom, when we are going to be observed that atomic size is going to be increases, but here we require that small atomic size. So fluorine F minus is going to be more favorable when compared to Cl minus, and Br minus is going to be more favorable when compared to iodine minus. So which has low atomic size, that will have that more favorable conditions to form anions. Okay, anion, here also we are going to be understand anion with inert gas configuration. When F minus is going to be formed, so we have the electronic configuration, this one 1s2 2s2 2p6. So in their outermost shell there are 8 electrons present should be there, and this is called as inert gas configuration. Anion with inert gas configuration is going to be formed most favorable conditions. And let me explain that what are the general conditions for what we can call formation of ionic bond. So these are favorable conditions for cation and anion, and let me go with the general favorable conditions. So generally the ionic bond formed, if you want to ionic bond formed means there should be a metal atom and there should be a non-metal atom, and electron transfer should be done by metal atom to non-metal atom. So generally the electron bond formed between the 1A and 2A, and these are called as S block elements, and it is going to be combined with 16th and 17th group, that is called 6th A group elements and 7th A group elements. So generally these groups will have the what we can call ionic bonds, and if you want to form an ionic bond, so there should be a electronegativity difference more than that 1.9. Electronegativity is going to be more than that 1.9. So when we are going to be observe that sodium, fluorine, so sodium and fluorine, so fluorine have that 4.0 and sodium has that 0.9. When we are going to be observe this electronegativity difference, this between sodium and fluorine, there will be a 3.1. So the electronegativity is less than greater than that of what you can call 1.9. So then only we are going to be able to form a what you can call ionic bond. Ionic bond having that maximum electrovalency is 3. So maximum electrovalency is, what is it? Electrovalency. Maximum electrovalency is 3. What do you mean by electrovalency? So the transfer of electrons. That means the metal atom should be loss or non-metal atom should be gain. So how many electrons are going to be lost by an atom, or how many electrons are going to be gained by an atom is also known as electrovalency. So the maximum electrovalency is what you can call for ionic bond is 3. And also if you observe that there is no 100% of ionic compound, at least there is some percent we have a covalent character in that ionic compounds. So there is only one compound which is going to be formed by non-metallic elements. So that is a one ionic compound which formed by non-metallic element called as ammonium chloride. This is a one element is going to be formed by non-metallic elements. And the strongest covalent bond formed between the cesium and fluorine. The strongest bond formed between the cesium and fluorine. So this is going to be what we can call ionic bond. General conditions we are going to be taken. So what are the characteristics it has? We are going to be see that also now. So when we are going to be see that characteristics of ionic compounds, they have hard in nature. They are hard in nature. So when first point is they are hard in nature, and if they are in hard in nature also, they are brittle. They are hard and brittle in nature. They are hard and brittle in nature. So they have high melting and boiling points. They have high melting points and boiling points. And the ionic compounds are going to be involved in ionic reactions. Ionic reactions such as neutralization reaction, precipitation reactions. Okay, then ionic compounds are soluble in maximum in water, and they are polar, what you can call polar compounds. So here water we can call it as polar solvent. So the maximum all of the ionic compounds are going to be dissolved in water. That's why all ionic compounds we can call it as polar components. And ionic compounds do not conduct electricity in its original state, that means solid state. So solid state, it does not conduct any electricity, but when it is in having that molten or aqueous solution, it is going to be so when it have that aqueous solutions, it have that what you can call flow of electricity, and it is going to be form anions, and it has flow of electricity, and it does not have any stereoisomerism. It does not have any stereoisomerism. And so this is what you can general characteristics of ionic compounds. I hope that you are going to be enjoy my video. Please, if you are going to be enjoyed this video, please do subscribe my channel, and thank you one and all.